In today's video, we are going to see some of the problems based on work done under a constant pressure. So the problem here given, students, which is very important thing that you have to see whether the word reversible is given in the question. If the word reversible is given, then you have to use W max equation. If you read out the question, there is no W max, that is because the reversible word is not there in the question. So let us start. First you write down given. They have given N is equal to 3 moles. 15 dm cube is the volume, that is your V1. V2 they have given, that is 20 dm cube. I can calculate delta V, that is V2 minus V1. It will give me 5 dm cube. And the constant external pressure they have given 1.2 bar. So let us write the given formula. So formula used is W is equal to minus P delta V. So that is minus 1.2 bar into 5 dm cube. So this will give you minus 6 bar dm cube. So your first calculation is over. Now they want you to calculate the work in dm cube bar as well as in J. So let us write down 1 dm cube bar is equal to 100 J. Therefore, 6 bar dm cube is equal to how much? So your answer here will be 600 J. So with the negative sign, because the negative sign indicates that it is the work due to expansion. Let us see the next problem. Let us see this problem now. Calculate the constant pressure. So they are asking you to calculate the P external required to compress. Number of moles are given, that is 2 mole of an ideal gas from a volume of, so V1 is 25 dm cube. V2 is 13 dm cube. The gas is getting compressed and the work is given, that is 4862.4 J. It is very important to note here that the volume which is given here is in dm cube. The pressure what you can get here, it can be in bar. If I convert this J to bar, so dm cube, that is J to bar dm cube. So let us do the conversion for this work into bar dm cube by using the same equation. So how I can do that? I will convert this. Let us check whether this is positive. So because the gas is getting compressed. So 1 dm cube bar is equal to 100 J. Therefore, 4862.4 J will correspond to how much? So it will be 4862.4 divided by 100. So it will be 48.624. It will be dm cube bar. So I have converted this to dm cube bar. Now let us go for the formula. That is W is equal to minus P external delta V. So work I will substitute 48.624 is equal to minus P into delta V. Let us calculate delta V here. So delta V is how much, student? 12 dm cube. So it will be into 12. So P external is equal to, now if I see this work I think is given in, yes, this will be minus 12 here. So this will be minus and minus will become positive. So it will be 48.624 divided by 12. So your P here will be, if you simply divide this by 12, you will get 4.052. Now the unit here will be bar. So this is how you calculate this problem. Let us see the next problem now. Let us see this problem. 200 ml ethylene gas and 150 ml of HCl gas. If I see the equation, so the required equation here, this is the required equation. First we have to check whether the reaction is balanced. So here the number of moles on both the sides, they are matching. Now if I see the physical state here, that is gas. So which law I can apply here is Gay-Lussac's law. According to Gay-Lussac's law, if I have one volume here, this is one volume here. So how much of this ethylene gas they are taking is 200 ml of ethylene gas, they are reacting with 150 ml of HCl gas. But out of 200, only 150 will react with this and 50 ml will remain as it is in the reaction mixture unreacted. So one volume is equal to 150 ml. So how much of this is getting formed is 150 ml. Now out of 200, as I said, only 150 ml is getting consumed. So only 150 plus 150 will give you 150 on the product side. So let us convert those volumes in. So how much will be this is 150 plus 150 of the two reactants. This will give you 300 ml. Means it is 0.3 dm cube or liter. On the product side, it is 150 ml, that is 0.15 dm cube. So this is your V1 and this is your V2. Now what pressure they have given is 1 bar pressure. So pressure is 1 bar and now they want PV type of work, that is W. So W is equal to minus P external delta V. So W is equal to minus 1. Let us find the difference between the two. It will be 0.15. So it will be 0.15 dm cube. This is in bar. So this is equal to 0.15 dm cube bar. Now they are asking you to calculate the PV work. It's always better if you calculate that in J. So what I will do is I will convert this. So 100 J is equal to 1 dm cube bar. Therefore 0.15 dm cube bar is equal to how much? It will get multiplied by 100. So your answer there is 15 dm cube, 15 J. So this is the answer. So how much of the work is done here is 15 J. Thank you, students. One very important thing what I want to suggest here, if you see the problem here, it is just by using Gay-Lussac's law, we can predict whether the work is because of expansion or compression. For that, I will write the equation. This is a hint to predict the sign of work. So, plus HCl gives you C2H5Cl. Here, 1 plus 1 means 2 volume is becoming 1 volume. Means there is a decrease in the volume. When there is decrease in the volume, the gas is getting compressed and therefore W must be positive. So what work they have given or what work we calculated for this problem was also positive. If the same question might have given for the ammonia decomposition, say for example this, then I will balance the equation first. Now if you see the equation is balanced, 2 volume is becoming 1 plus 3 means 2 volume is becoming 4 volume. What has happened to volume? Volume has increased. When the volume increases, when there is expansion of the gas. And therefore, for this type of problems, W will be equal to negative. Means the work will be done by the system on the surrounding for this equation. For this equation, work will be done by the surrounding on the system. So this is a shortcut to predict whether the work is done by the system or on the system. Thank you, students.